Hey Math Stars, welcome to Math today. We are going to be working on renaming fractions. Let's get started by reviewing how to count by 6. We're going to use the number line to help us do it. Okay, here we go. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6. My number line goes on, but we're going to stop here for today. Let's zoom in on 7 6. That's where we're going to keep our attention today as we're working and thinking. Because I want to know if there's another name for 7 6. Let's use the idea of writing fractions as sums as well as the number line here to help us do this. So if we're counting by 6, what is 1 whole? Shout the answer in 3, 2, 1. 6 6. Great thinking. And I'm going to write that down here so I know that. Okay, so 6 6 equals 1 whole. Then for 7 6, there's still one more 6. We know it's larger or greater than 6 6. So let's write it as this. 7 6, because remember we're trying to see if there's a different name or we can call 7 6 something else. Let's decompose 7 6 to be 6 6 because we know that it already has 6 6 in there because it's greater than that. All right, so we have that represented here, but I still have one more 6. So how could I show that? You got it by adding 1 6. Let's write that in. Plus 1 6. 7 6 to equal 6 6 plus 1 6. But before, we had a discussion about how else we could rename 6 6. Do you remember what we said we could rename it as? 1, you got it. Let's do that. So 1 plus that 1 6 we still have. Okay, so when I look at this, I have a whole, or 1, plus 1 6, and when I add them together, I get 1 and 1 6. So I can use fraction greater than 1 and rename it to a mixed number. Let's take a look at what this could look like with a different model. Okay, so let's take what we did before and look at it with a different model. So 7 6, which is our fraction greater than 1, we decompose to 6 6 plus this model of fraction strips to kind of connect what we did on the number line with fraction strips. So we took our fraction greater than 1, 7 6, and we have our fraction strips here. Let's just double check that we have everything we need. 1 6, 2 6, 3 6. I can't hear you, count a little louder. 4 6, 5 6, 6 6, 7 6. Awesome. So we decompose 7 6 to equal 6 6, which is equivalent to, you got it, 1 whole. So I'm going to lay that there because I know that 6 6 can also equal 1 whole. And then we added our additional 1/6 sized. So we took our fraction greater than 1, which was 7 6. Let's make sure we have everything we need. Count with me. Here we go. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7 6. Awesome. And we know that this equals or can be decomposed to be 6 6 plus 1 6. Awesome. We also know 7 6 is equivalent to 1 and 1 6. They're just named differently. We have our 7 6 size pieces here, and here we have our whole and our 1 6 size piece. But we know that we need 6 6 size pieces to make up a whole, plus our 1 and 1 6. So as we look at our model here, we see that 7 6 is equivalent to 1 and 1 6. They're the same value, they're just named differently.